This is part 6 of the video series I'm doing about building a startup from scratch in Paris. My startup is Potos. My compatriots are Sammy and Amin. Today I want to tell you about the technology behind Potos, revealing the process of taking a business idea and turning it into code. But first I want to give a brief update on my personal life. About 2 months ago now I first arrived in Paris, and the first challenge was to get a flat. Quite soon on I managed to find a flat, but it would take another 3 weeks before I could move in. I have since moved in, so let me introduce you to my new place. Voilà. Bienvenue chez moi. I have a studio flat in Bastille, a lively area with bustling nightlife. It has a bed, it has a kitchen, it has a sink, it has a sink. It has a garden. It didn't have a desk, but now it does. The only downside is that it doesn't have the far superior British sockets. I don't know how any British expat could survive here. I, for one, am barely hanging on. Okay. Technology. In Potos, besides being the resident filmmaker, I am the CTO, which in a bigger company would mean that I oversee the technology division. But in our small startup, it means that I write most of the code. So, let's write some code. Let's write the code for Potos. Let's see, what are the rules? Well, every month we charge all the members of the group. Then we select a winner and we transfer the pot to the winner. Done! We've made Potos. How great! No, that is not how it works. For a computer to do anything, it has to have absolutely no ambiguity. What we just wrote has a lot of ambiguity. Let me show you. First of all, every month? What do you mean by every month? What day of each month? What minute? What second? And also, how many months? Does this ever end? Is this forever? When does it start? Something that needs to be scheduled over time is much more complicated than just the idea of scheduling something over time. And what we started with there is the idea, and not the actual code for it. Okay, what about charging all the members of the group? What if one of them fails? How long does it take to confirm whether a transaction succeeded? And can it be that a transaction is initially confirmed and later on it's revealed that it did not succeed and it failed and you don't have the money? Spoiler alert, yes, that can happen, and it makes this whole transaction business much more difficult. What about this whole idea about selecting a winner at random? How do you guarantee that everyone wins exactly once? And what about this whole idea of transferring the pot? If people register to our website by giving their credit card details, can we put funds directly onto a credit card, or do we need to have their bank account as well? Their sort code and account number, or their IBAN? And speaking about bank details, how can we make this secure? How can we make it so that we don't have to store any of these details? What happens there? What happens if someone hacks into our website? All of these things are things we should be concerned about. And that's just considering this simplified version of a saving group. This is not what people want. What people want is the ability to pick between a weekly or a monthly version. So we have to add that. And after we select a winner, we want to give the opportunity for that winner to pick another person. And if they do, then the winner will be someone else. And we also want to give the opportunity, if you want to save until the end, but you want to do it with your friends, that you can leave the money with us until the end. Want to receive money at the end. Keep money. Else we transfer the pot to the winner. Now that we've got a slightly more realistic model for what a saving group should do, we have to actually build it. And that's when it starts to get very tough. So imagine we are running this code. We are here, we're on a particular month, and let's say it's not ambiguous. We know exactly what day and what minute and what second it is. Then we charge all members of the group, that's fine. We select a winner, and then we pick another... Oh, that was a crash. And that was intentional to prove a point. This can happen. And in fact, it happens all the time. There are thousands, if not hundreds of thousands, of breakable components operating on a server at every second. There are always many things on the verge of breaking that can interrupt your code. So how do you work around this? How can you make sure that nothing bad happens? Here's one strategy. Every step along the way, anytime you're doing an important action, you store it in a database. If you start withdrawing funds from 10 people, and after the 5th one, you crash before you get to the 6th, that should be in the database. If you withdrew successfully from all of them, and just before you decided on a winner, you crash, that should be in the database. The principle I work by when designing systems like that of Potos is that any piece of code should be able to crash at any point along its execution. It should be able to face any kind of interruption. Everything should be able to break, but never should that lead to a mistake. It rhymes. It rhymes. So let's go through another example. Imagine this is your database. Imagine this is a table in your database. Databases are just glorified Excel spreadsheets, or Excel spreadsheets are glorified databases. I don't know, but databases are a hell of a lot better. So here we have an example table in our database. We could have a row for a saving group, and we will capture the progress we've made in carrying out a single round of that saving group in each row. So you can imagine here we have a different saving group doing a different round, and we've got all sorts of stuff to do. Right. This is how we store the information in a database if we want to be as safe as possible. For each person that we charge, we label it that we've started charging them. And once we've completed charging them, we label that. And so we start, put that in the database, we do the charge. Once we're done, we put that we've completed it in the database. And we do this for all of them. And let's say we experience a crash now. All our information is gone. We recover it. We look at what the database has, and we see this. We see that person 1 and 2 have already been charged, and it succeeded. So we don't need to redo those. And we see at the end here that person 5 and 6 have not been charged yet, and we didn't even start it, so we can do those again. And then the 2 in the middle, person 3 and 4, we started charging them, but we did not succeed. And that's where we have to check. So in this case, we'll have to go to Stripe, our payment provider, and ask them, did this transaction successfully happen? Because we didn't note a success in our database. And from them, we can determine whether or not it succeeded. In which case, we might find that person 3 succeeded, and we can turn that into a success. But person 4, they didn't note any transaction. We might have crashed before we ever talked to Stripe. And so we reverse that back to nothing, and we can retry it. Then all of these could succeed, for example. Then we pick a winner, say P4. Then we do the transfer. We start the transfer. We say the transfer succeeded. Here, every step along the way, we know what's been done, what we're doing, and what still needs to be done. And whenever the program that's actually doing the work crashes, we can recover exactly to the point of when it crashed what it was doing. So yeah, that's it. Actually, that's not it. To recap, we started with the basic logic behind a saving group, and then we focused on the ambiguity that you can find in our basic program. Next up, the fact that there needs to be much more flexibility in how the program operates based on what the user desires. And finally, how we have to be resilient against crashes and interruptions and any kind of problem by logging it in the database. With that, we're probably around 10% done with what is necessary to make something like Potos. All I described so far is the backend, and really only a subsection of the backend. A front end, a view for the user into what the backend is doing, is just as important. Building a clear dashboard is very important. A dashboard where the user can see exactly what their group is doing, when the next debit is, if there are any issues that need to be resolved, and if they've won, whether they want to keep the pot or give it away or do something with it. And additionally, a whole host of emails will have to be sent at all times, reminding the user that a round begins tomorrow, for example, or telling the user that the round began and they charged everyone, but one of them failed and you have to sort this out in the next 24 hours. Or that you are the winner and you get to choose what to do with the pot. It doesn't matter how resilient the backend is to mistakes if the user doesn't see what it's doing anyway. So maybe we'll talk about all of that another time. But you get the picture. A simple idea like a saving group can very quickly become a complicated technical challenge. And right now we're in the midst of unraveling this challenge and seeing it through to the end, actually building this thing and releasing it to you. Hopefully we can do that over the course of the next 3 weeks and have an actual working version for you to try. If you're interested in trying it, you can sign up on our website to join the beta. So the wind is picking up. I think I'll stop filming there. That is very nice. That is very, very nice. Nice. I'm going mad. 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 I am though. It's not a joke.